This is Advanced Placement Pre-Calculus, Lesson 8. Today we're going to be looking at analyzing functions graphically. Let's go ahead and review some of these different functions that we have. First off, we have the identity function. The identity function is basically linear. The second type that we looked at was a cubic function, and you'll notice that with the cubic function, it's going to go up, it's going to take a curve, and then it's going to go back in its original direction that it was traveling. We could flip this over simply by putting a negative sign in front of our cubic, and it would go down. But it would have the same basic pattern, it would just be upside down. The square root, we cannot have negatives in the square root unless we do some shifting, which is part of what you're going to be learning in today's lesson. It's going to start at a point and it's going to go off indefinitely. The natural log, if we were to cut off this portion of it, it would look very similar to the square root function, but with a natural log, it's going to go off to infinity in one direction, but in the other direction, it is going to get closer and closer to an asymptote. The cosine function goes up and down. It is very similar to the sine function. It's just shifted. And so when we work things out, it's going to be difficult to tell whether it's a sine or a cosine because we could have either one drawn as we do some shifting. We'll learn that in the trig portion toward the end of the school year. The greatest integer function, it looks like stair steps going up. So it has one point that it starts at and it goes up to, but not including another point, and then they jump. So it's a discontinuous function because there are no values in between. Coming over here, we have the square function. That is the quadratic, and you're very familiar with from Algebra 2. And we have the reciprocal function. The reciprocal function looks kind of similar to the natural log function, except for you'll notice that here there are two asymptotes. If it's in the basic position, both the x and the y axes are asymptotes. So they're going to get closer and closer to those values but never touch. They're also mirror images over y equals negative x. The next one is the exponential function. That's where we have a asymptote near the bottom, but then it goes off and grows indefinitely. We already talked about the sine function. The absolute value function is unique because it has the V shape. And then we have logistic function, which has two asymptotes. It has a lower asymptote. It grows what seemingly is exponentially, but then it starts to taper off and goes closer and closer to a second asymptote. So those are the 12 basic functions that you want to know, and you want to know them very well so that as we work out problems, we can work them out more quickly because you'll recognize certain aspects of them. In today's lesson, we're going to be looking at how those pieces get shifted, and as you do your homework, don't just go through the motion, but rather when you get done with a question and you're looking at the questions that they've asked, make sure you understand what they're trying to teach as you go through those questions. So that brings us to analyzing functions graphically. Today we're going to be using the calculator. You're going to be using the calculator quite a bit on your homework tonight as well, because the further you understand some of these basic aspects of the 12 functions, what causes them to shift, what causes them to expand or grow more slowly, you'll be able to work problems out more quickly, even without the use of a calculator. You'll have a basic understanding of what they look like, how they're manipulated, and you may not even need a calculator. When you take the SAT, you might be able to answer a few questions much more rapidly because you don't actually have to use a calculator. You can look at the possible answers, eliminate 3 out of the 4, and go straight to the answer just knowing some of these pieces. So let's begin by turning on your calculator. Go ahead and hit y equals, clear out what's ever in those y equal equation values, and we're going to type in parentheses x minus 2 in parentheses, and then we're going to square the entire parentheses. Now before you hit graph, I want you to go ahead and change the window. So hit your window key, and we are going to change the window to where our x minimum is negative 4.7. Our maximum is 4.7. We'll keep our scale at 1. Our y minimum, we are going to make a negative 1.1, just so we can see the negative 1 piece there below. And we'll make our y maximum a 5.1 so that we can see where 5 is located. Make your scale for the y 1 as well. Now, when you hit the graph button, you should get a graph that looks something like this. So it has the basic square shape, the parabola shape, but you'll notice that it is not at the origin anymore. Its minimum point is no longer at 0, 0. So let's take a look at what is happening with this function and why it is shifted to the right. And let's begin by asking some basic questions as to where is it increasing and where is it decreasing. Well, it is decreasing from negative infinity all the way to this point right here. Now, based on the graph, that point appears to be at 2. We can double check that with our calculator. If you hit the second function calc key or the trace key, you can go to either 0 or minimum. I'm going to do minimum. We need to enter in a left bound portion by hitting enter on the left side, and then a right bound portion. So if you scroll over to the right hand side of your minimum and hit enter again, in between those two, you'll notice that it is basically 2. So we're at 2.0. So that is my minimum. So it's decreasing from negative infinity to 2, and then it's increasing from 2 to positive infinity. The next question is the function odd, even, or neither. So think about what does it mean if it's odd, even, or neither. If you recall, an odd function is if we were to rotate this 180 degrees. If we rotated this 180 degrees, it would not look exactly the same as it does now. So it's not odd. What does it need to look like in order for it to be even? In order for it to be even, it would need to be symmetrical about our y-axis. Here, if we rotated it or flipped it over our y-axis, we would not get the exact same look. So it's not odd, it's not even, therefore we would consider it neither. What are my extrema? Well, we kind of already looked at that when we were looking at where it was going down and when it was increasing. But our extrema is only one. It doesn't have an upper boundary. It only has the lower boundary, and that lower boundary is located at 2, 0. And was there any shifting? In this particular case, yes, there was shifting. We shifted it to the right. How far to the right? 2 units to the right. So these are the kind of things that you're going to be doing in your homework tonight. You're going to be graphing the function. It'd be great if, before you even graph it, if you look at the equation and try to figure out mentally what is it going to look like, and then graph it and see how close you are. Hopefully, as you go through your homework tonight, you'll understand more and more, and you'll be able to visualize it better and better with each one that you do.